So at the beginning of the project, we didn't even know if perovskite could deliver the efficiency that were just seen theoretically. Because at the beginning of the project, so 3 years ago, perovskite silicon tandem devices were at an efficiency of 15-16%, something like this. So very far away from their potential of above 30% that is normally used in projects. And clearly, if we compare this 15-16% that we had 3 years ago and the 26% that we have now in the consortium, or even 28% from Oxford PV, we can measure the leap we have made in the progress we have made in efficiency. The other question was, of course, the stability, which is kind of the elephant in the room when we speak about perovskite. And again, I mean, 3 years ago, maybe perovskite layers, they were surviving for a few hours when you were not encapsulating them, etc. But now we have seen that with the improvement of the perovskite material itself, but also the contacting layers that goes around the material, we can have devices that can withstand, so not all of them, but some of them can withstand standard degradation tests that are used by the PV industry. So these are, I mean, clearly these are questions that have been answered thanks to chaos, and that represent a great progress. Now the question that we are facing for the technology is more on how all these processes that we use to make perovskite can they be upscaled. So they can be upscaled, that's what we start to see, but can they be upscaled in an economically efficient way that makes sense for large-scale industrial manufacturing? And that's typically the question that the next project dealing with perovskite will have to deal with.